goes and the direction it's headed, well, that may be even more serious. Tell you what, you stay right there and we'll do more. All right, this is really something. Back now to Dr. David Anderson and our caller. And caller, if you would rephrase your question quickly.
Yeah, I was just curious of what frequency range he was tested in.
Well, it's a two-part answer, Scott. As I mentioned, that there are two things that happen with frequency in our experiments. The first one is we do induce a rotational magnetic field. There's two components to that frequency that we use. One of them is just over the 10 meter band, just over the TV band. The other one falls right at about 405 megahertz, which is probably going to fall very close to probably, I don't know, where was the Philadelphia experiment at? I'll tell me before 405.
Actually, it was 130 or 40 megahertz, I believe, and then later 400 megahertz.
What's interesting, as I mentioned before, those guys, is that the frequency that we use, or just the fact that we're inducing the rotational electromagnetic field, is important for stability, but it's not a key fundamental thing. The other place where frequency plays a role, as I mentioned, was in the Doppler effect. Whatever we place inside the field, if it's outside the field, when it passes through the boundary layer, how it gets Doppler up or down. Did I answer your question?
Yeah, well, theoretically, time travel be able to let you get 8 hours of sleep in 4 hours.
I think that's personally, that's my number one goal. I want to figure out how not to sleep. I always think about the notion that by the time I'm 60 years old, I will sleep for 20 years, and I can't afford that much downtime.
Fewer slices of death.
Mark, keep us up to date.
Okay, thank you. All right, I've got one for you. If time travel were possible, I understand this calls for speculation on your part, but I just thought about this. If time travel were possible, and we could go truly into the past, and you did a very safe experiment, and took somebody who had just died and moved them into the past, would we have in the past a dead body or an animated body?
You would have, my personal belief is a dead body. I'd say the alternative would be to go back before that person died, then take them into the past to give them more time. But I think what all the relativistic facts that have ever been tested since the 1960s all show that type of effect wouldn't happen. A dead body taken back would be dead. But if you went back before the death, picked up that person and took them back, then you would have to give them much more time, depending on why they died.
Or moving toward one of your hoped-for applications, you might move back in time and find the person had a weakened artery wall that was about to kill them, and or did kill them in a certain time, and move back and after the autopsy, go back and medically repair that before the
One of the interesting possibilities, absolutely right.
West of the Rockies, you're on the air with Dr. David Anderson. Hello.
Hello, Senator Bell and Dr. Anderson.
Hello.
I called to comment about the relationship of space to time, but may I say one thing before that? I was so happy to hear Dr. Anderson talk about the fact that he thought we exist in a sort of a false reality, because that is exactly what the Ascended Masters teach. They are the higher spiritual beings. They say we do live in a false reality, and they say in reality there really is no space or time. But with that said, speaking of space and time, a long time ago, many years ago, it occurred to me that space has some kind of a relationship to time. And it seems that I've proved it to myself over the years. If I live in very close, very small quarters with a lot of things around me, especially if they're not kept in good order, etc., I find I'm very, very limited in my time. Then when I have more space and larger quarters and I don't have so many material things around me, I seem to have very, very much more time. And I think that probably would affect everybody that way and they haven't realized.
Is there that relationship, Doctor?
I don't know. It's probably something I'm not qualified to comment on. When I speak of space and time, I'm looking at it more. I probably have to apologize to your caller because I think I've spent too much time in the world of pure analytical science. But I don't discount what you're saying.
Yes, well, I'm certainly enjoying your program very much.
Okay, thank you very much for the call. I think I understand what she's saying, but I understand also why you would not have an answer for that. But it's interesting. Hi there. First time caller line. You're on the air with Dr. David Anderson.
Hi, Art.
Jason, you're going to have to yell at us a little. You're not too loud.
Okay, hi, Art. My question for Dr. Anderson is, with your time alteration experiments, have you ever attempted these experiments with the clock mechanism shielded in like a metal ball, something that was completely isolated from the electromagnetic field that you're generating, but still placing it within the boundary layer? And would you have any measurable time dilation effects under those conditions?
The answer to that question is absolutely yes. We have we've used a number of different materials with a lot of different, I guess I'll say, characteristics with different permeability and permittivity, from metals to synthetics and other things. And we have seen no effect as a result of having a block inside a shield, which was interesting to us. We weren't sure exactly what to expect. We finally got the field size larger. We were able to run those experiments, and we have not seen any detriment to having everything within the shell of the boundary layer affected with the time rate diversion.
So in other words, the shield and the clock itself would be equally affected. Caller?
Yeah, that makes good sense. It's a gravitational effect.
Sure does.
The other one that I would ask is if you have a outside of the transition region and it reflects or it passes through the boundary region, reflects off of the object and then comes back out, the Doppler shift through the transition should be linear in both directions. Is there any polarization effect? You mentioned it darkening, but is there any other blurring effects or things of that nature in light that bounces off of the object?
Well, this conversation gets a little complicated because when the object we put inside the field has a light source, and many times we do that, we put a light source within the field with the object and the reference equipment that we're using. That light source and the light that is reflecting off the object and out is filtered out. Going into the field, what's interesting, you talk about light sources. If you think about this for a minute, we have a laser array of 12 lasers firing into this field. And when the Doppler rate is accelerated, when the frequency is accelerated as light passes into the field, we have exactly what you say. And we really haven't looked at, like for instance, the laser ambient light as it goes into the field coming out, any polarization effects. It really hasn't been.
That would be coherent light, so it should be pretty easy to notice any effects that would cause. I was just wondering if it might be like a blurring effect, like heat distortion, like you'd see in a desert road. The only reason I really ask that is that over the years there's been a number of photographs taken of UFOs, and a lot of these photographs, some of them are blurry, and I mean a lot of it you could write off to just camera work. But if some of these blurring effects is like a Faraday rotation or some sort of magnetic response, then maybe there's a parallel between some sort of UFO propulsion mechanism and what you're working with.
Doctor? Well, we see when you talk about the blurring, this is going to be different. I'm not saying what you're saying towards what we're seeing here. But the boundary layer is not, it's not a purely linear and stable in every range where we experiment and test. When we have a light source inside the field and we're looking at an object, there is some blurring, but I don't think it would be similar to the same effect that we bring.
So are you then constantly striving to stabilize the field?
The field is very stable from accelerating to 300% and slowing down time rates down to about 15. But here's the issue. What we really want to do is, and we've done it, we've gone down to a zero time rate and tried to approach a negative time rate inside the field.
Right.
And And as we do that, though, as we get to 10% of the reference time rate, which again is the rate at which time passes outside of the field, we have an instability where the boundary layer starts not collapsing, but it enlarges or shrinks to the core of the field. And that's a problem. If we ever want to be able to regress the feed, we have to solve that problem.
All right. Wildcard line, you're on here with Dr. Anderson. Hello.
Yeah, your anomalous power source is probably coming from a different time of your experiment.
It could be. It could be. I have absolutely on that unexplained power that we're seeing. We know it's there. Either put it this way, we know a couple of things. We either know that again, what we're seeing is when we create a field, the power we're providing isn't enough to keep it open. So we either have equipment that's in error, which we ruled out, or the laws of physics are wrong, which we don't think they are, or there's a power source coming from within the field, and you're very well right. Maybe it's coming from the power that we're injecting at other times, from the field ourselves and not from another universe. Who knows?
We measure speed of light by...
Hello?
Yes.
What happened to him? I guess he went away. Oh, well, we lost him. Doctor, have you ever, in a wild moment, wondered, sitting in the lab, whether one day you might, get a knock at the door, and there is an old, gray Dr. Anderson saying, "Hey, you want a quantum leap?"
I've wondered. I think one of my personality flaws and personality strengths is I'm a little too focused on my work. I live for my work, probably 12, 16 hours a day. So
I understand.
I don't give a lot of thought to it, but at times it does cross the mind. And the other question, maybe I can anticipate, a lot of people say, if you ever do expand the technology and to a point a human can step inside, go anywhere, where would you go in time? And I don't know the answer to that one either.
Is there any reason why that couldn't happen that you can imagine? In other words, as we imagine the power that you can't account for, perhaps coming from other experiments you have performed in the same rough place a year or 2 years or 10 years from now, then we might also imagine the possibility of, in other words, could it happen? Could you come back, providing yourself a quantum leap in technology, or would that be disallowed with what we understand or think we might know about the nature of time?
I do not think. I hold firmly my ground, and I think the 20 physicists in the room, 19 or 20 would agree, is that it is not precluded.
Not precluded.
It is not precluded that a person can travel back into time. It may be incredibly difficult. It might be incredibly difficult to achieve either the power or a lot more work to do on technology, but it is not impossible. It's not highly impossible.
Well, then, how about this one? If time travel is to be possible, no matter when that might be, the big question is then where be all the time travelers?
That's a good question. That's a good question. That's the one that's used to, that's the one Stephen Hawking used in his chronology protection conjecture that we talked about earlier. He says his rationale for belief that there is time travel is impossible because we're not overwhelmed with time travel. One of the most common views is that, and Frank Tipler holds to this, is that when the first time machine that a human built, you won't be able to go back any further than the day and time that the time machine was first constructed. And I don't believe that. Who knows? Perhaps it's explained in some of the theories of parallel universes and hyperspace. Another one is the parallel universe theory that says if you go back and alter the timeline, the original timeline continues, but the parallel timeline branches off. Perhaps that is an explanation. I'm not sure I agree, but perhaps it is.
So that you would change an event and events would continue in that timeline based on that change. On a totally kind of like on a separate highway, but the original highway would continue on unchanged. Is that correct?
So at any point in time, there are literally an unlimited or an infinite number of parallel universes all progressing into time.
Wouldn't we vastly complicate that with time travel? We would begin to cause all these branches.
It's possible, and you brought up that issue before. Are there dangers to the technology? Who knows? Maybe that could be one of the points.
Do you, with your team, spend much time talking about these dangers?
We talk about many things.
What are your worries?
Our biggest worry is to resist the temptation to try to test on a living person or animal too quickly. Because we want to make this leap. We want to get.
What's a mouse? What's a mouse, more or less?
What's that?
What's a mouse, more or less?
It depends. It depends on the individual you're asking the question to. It really does.
I'm asking you.
You're asking me.
A mouse, more or less. In other words, how can you resist that temptation?
I believe personally. I believe that the use of animals for testing, provided it is for a greater good, be it for animals or people otherwise.
Yes.
Reckless use of animals for scientific testing is something that just is very politically.
You're pretty sensitive to the issue.
Yeah, very sensitive to the issue. The biggest reason why I'm sensitive to it, Art, is I don't have strong feelings along that line. But what I don't want to see is our research and advancing our research to become a political movement or issue. And if we try to test on living animals too quickly, if we had a mishap, it could really affect us politically, and it really could really affect our real research.
Have you read Crichton's latest book?
What do you mean?
I'm trying to remember the name of it myself now. I just read it.
Oh, you know what? I have it sitting here. I should know that.
My wife is yelling it from the other room and I can't hear it. She'll come in here and tell me in a second. It's important.
Oh, timeline.
Timeline, thank you.
The answer is I have the audio tape that the plastic store wrapped around. So
In Timeline, they achieve time travel, but one of the very difficult side effects of it turned out to be something called transcription errors. In other words, some of the people who are incorrectly sent through time and returned end up, for example, they do an MRI on the person, and a blood vessel that should be connected in an ongoing stream, as blood vessels are, suddenly is disjointed by a quarter of an inch or an eighth of an inch, with obvious horrible effects. Transcription errors, they talk about.
Yeah, I think honestly, I think the whole team is really less sensitive to that. Again, in the case of relativity theory application, anything that's experiencing a relativist, provided it's not caught in, let's call it like a boundary layer, you're not going to have that type of problem. I think in teleportation, that's always a big issue.
I know IBM is working on that.
Yeah, and that's a huge issue. As a matter of fact, there's a really interesting article in Scientific American about quantum teleportation this month, and it talks about this as a possible risk. I think the biggest question we have that we can't seem to get our arms around is, and it's not critical to our research right now, but we want an answer, is if we send an object back into time with slow time rates and we accelerate time rates and we're moving these objects forward,
Right.
and this, when we expand this to include a living animal or person, we don't see a risk of transcription errors, right? But what we see is an unanswered question, and that question is, if we move a person forward in the time or backward in the time someday, does their soul go with them?
Oh, God.
And that's a question that is one I'm not even ready to try to
I'm
answer.
with you. Oh, boy, am I with you. Listen, I have one more hour. Can you afford one more hour?
I will make it happen.
All right, let's make it happen then.
It's been a too long time with no peace of mind, and I'm ready for the time to get better.
Maybe with this technology, we won't have quite the same weight. That occurred to anybody out there? I'm Art Bell.
you have been racking my brain, hoping to find a way out. I've had enough of this continual rain. Changes are coming, no doubt.
All right, I've got one of those difficult breaks that I've got to get done here, so we'll just kind of take it as it comes, and here it comes. All right, Dr. Anderson, welcome back. You said something very interesting. You said that if you were to move a biological entity, a person, you might move the physical person, but not the soul. And that was a concern, right?
That's a question we ask ourselves, yes.
I went into the other room and I asked my wife that if she heard that. She said, oh, yes. She said, well, maybe the soul is just excess baggage and you pick up another one when you get there.
Well, maybe a better one.
I don't know. Maybe souls are automatically installed in bodies wherever they may be, the same or another one. Who knows? Interesting. All right. Anyway, listen. Here's what he wants to know. How much power reduction to achieve the results you're getting are you achieving compared to the theory of what it should be? In other words, how much percentage-wise, how much power are we talking about here? Can you tell us?
Yeah, it's substantial. It's we do our estimates. The amount of power we're injecting into the field is only, I'm going to say roughly, depending on the specific experiment, but it's roughly about 70%. So it's substantial.
Has that remained relative? My God, 70%. Has that remained relatively constant, or has that changed?
Depending on where we're at in terms of accelerating, where we are in terms of what time rate we're trying to accelerate or decelerate to, it varies slightly. But on average, it's right around 70%. But there is a variance in each question, too.
Boy, that's astoundingly large. And I guess that's how you're thinking about all kinds of things.
Oh, yeah, the question is, is this energy coming from hyperspace, from we still ask the question, maybe are the laws of physics wrong? We don't like to think they are, but and we don't think they are, but
they might be.
Another area where we have more questions than we have answers, but we are working on that one very specific.
All right, how about this? Please ask Dr. Anderson, John Auburn, Alabama, if he knows about the Einstein Gravity Probe B, a spacecraft designed to test how the Earth's mass warps space-time. Seems to be the $70 million over budget project by NASA is attempting to test something that has already been proven.
What was his name again?
John.
John, actually, it's interesting because I believe John wrote me an email earlier today.
All right, well, he's not quite done. The Einstein probe is anticipated to provide new and stringent tests of some of the predictions of general relativity. In particular, the spacecraft is designed to test for frame dragging by the Earth as it rotates in space.
Yes, I know. That's why I have to say this is where I get sometimes a little frustrated on where we spend money. The concept of frame dragging is something that
Old news?
It's old news, yes. And I'm very familiar with what they're doing with the probe. They are trying to measure the effects of frame dragging of the Earth and the fluid. And you know what? In a way, I'm kind of happy they're doing it, but for the amount of money that's gone into this project, I think there's other places they can invest.
If deceased spirits are in fact existent at a higher or faster frequency, could they potentially be seen by placing a camera inside your field and speeding up time inside the field? I know that's a wild...
I have to think about that question before I answer. If you put a camera inside the field, over top of,
and you're looking outward.
The answer is there are other ways to do that. You don't need a time warp field to do that. There are ways that there are cameras that will, for instance, look at X-ray, ultraviolet light, visible light, and take that information and you could digitally bring it down. And there's actually a lot of systems out there that do that today. Believe it or not, I actually think a lot of paranormal organizations, paranormal experiments, they actually use what that today. So the answer is yes, you could use a time-warp field, but it would be overkill.
It would be overkill. Still, though, it might prove conclusively we're always after this, chasing this life after death thing, and whether there are really, whether there is an existence after death. And I'm not sure it would prove that, but if you saw entities of a different sort, you would indeed be proving that there is an existence at a faster or higher frequency that you simply cannot perceive presently. You would prove that, maybe in an overkill way.
You know, it's interesting because we talked about some of your professional acquaintances who are studying the ability of the human mind to time machine. What's interesting is we know that special relativity from Einstein, that a body that approaches or travels near the speed of light essentially transcends time. The future becomes the past, time dilates, and you see all that effect. You also look at it though, you say, well, let's look at the human mind. How does it work? The human mind is an energy-mediated process. It works off of energy that travels very near the speed of light. Is it possible that the human mind is a time machine? But even more importantly, what you brought up were what happens to death? What happens to the energy in the human mind? When the energy is released, does that energy stay? Does it materialize? Or when an object dematerializes and dies, does that mean you move into a place of different energy? There's a whole bunch of theories out there that we get hit with every now and then. We're not experts.
Or different frequency. I mentioned to you, Bob, and he's got a ranch at a place that I don't talk about. It's I'm sure you've heard about it. And somebody observed using night vision equipment, the oddest thing. One of the scientists there actually saw a kind of a hole form, defined. It was defined by light, by a circle of light, and saw a creature or a thing or something come through, and then saw that disappear.
Well, you know, you asked me the question for the break about, and I'll tell you, I'm not going to say that this is my view, but it's just a very interesting side. A lot of people ask me the question after our technical presentation, well, where are all the time travelers?
That's right.
Technology is created. Well, how come nobody has seen it? Well, the answer is, some people say perhaps. What about the tens of millions of people who claim they've seen extraterrestrial visitors?
Absolutely.
Is it possible that they're time travelers from our future?
Absolutely. It certainly is.
It opens up a whole fascinating area.
All right, going back to the phones in a second, but here's another really good one. Steven says, may have missed it earlier, but what happens to objects that enter or leave the time warp field or pass through the boundary layer while the apparatus is turned on? For example, what would happen if you fired a shot from a gun of some kind into the field?
Well, that shot, obviously, the time rate slows down and you can see the physical effects of that. Again, remember the window that we're working with, accelerated time rates in the field to 6%. And we've decelerated it down to about, successfully down to about 13%. You will see, when you put a material object through the field, you'll see the physical effects of it as it was, moving faster through time. If you put a living object through the boundary layer, it would be a very bad thing. As a matter of fact, when we start our experiments, we always initiate the field and then put the object in the field before we adjust the time rate.
We were talking earlier about transcription errors. Now, if you were to put a living object through the field, an operational field, is that the horrid result that you might get?
Well, it depends on how high we have the time rate divergence. Here's what happens. Say I would take my hand and I would place it inside the field. Why it was modulated so there was a time rate divergence. So right at the time was talking about, the time which greatly accelerated the field. The heat of the time in would be gobbled up with higher heat, higher energy.